Hello, everyone. I'm Alexander Talashov. I'm one of the co-founders of GPU Audio, the world's first technology that unlocks and enables GPUs inside your desktops and laptops for accelerated audio computing. Today, Jonathan Rowden, my co-founder, and I will be speaking about the company's mission, vision, and we will present you the ways we want to collaborate with everyone, the developers community, businesses, and customers, consumers, users. So first of all, please let me express my gratitude for the offline part of the audience, and thank you for joining us today. I know it was a little bit hard to make a choice, especially when one big company does a really big presentation in another room. So thank you for joining us today. And let's start over, shall we? Jonathan, I'll let you begin and tell a story about our company and our traction.
All right, fantastic. So, hi everybody, my name is Jonathan Rowden. You've probably, if you've interacted with our company before, you've probably seen me talking. I wish I could be there in the UK with you guys. I just can't right now. So I'm glad that this is working out, and it's really interesting to be doing a hybrid presentation like this. So GPU Audio is a new startup company. I'm sure you guys are familiar with us at this point after the last couple of days. But about us, we were founded in Switzerland originally. We recently incorporated in the United States, so we're now a US-based company. Our original company name was BrainGens, which is when you email us, don't send us to spam. That's our old company name for the R&D side of things. And then we adopted the name GPU Audio because it just made more sense to associate ourselves with the tech that we're so focused on. So GPU Audio originally started basically as a sort of a dream to power up a few music sessions. Just like, hey, musicians all over the place and friends of ours are asking, why can't we just use our GPUs to power up our plugins? Is there a way we can do this? We wish that we had, more options. So it began as a personal project between Sasha and his friend Basil, but it ended up blossoming into a real solution that appeared to be more useful as a standard than a one-off project. So that's basically how the journey started. Now we're a thriving startup. We have over 40 people. It kind of ebbs and flows depending on projects. We're representing, I believe, over 13 countries now. It's a very smart team. We have at least 7 PhDs on the team right now, maybe another one coming in soon. On the engineering side, in computer science, GPU science, and then obviously musicians and producers such as myself. So the core team of our company includes Alexander, you met him, our CEO. He was also the original CTO. We have Vasily or Basil Sumatokin, who is our CPO, originally an audio engineer. We have Alexander Prokopchuk, our current CTO, who's amazing. And then we have myself, the CBO, and I also come to you guys as a fellow musician. So our team is made up of a combination of music producers, audio engineers, GPU and computer scientists, all around awesome people. But between all of us, we share one common goal. Our common goal is to unlock creative potential through accelerated computing technology. And this is sort of a phrase that we've coined as the accelerated audio computing industry. So our community is growing pretty quickly. Earlier this year, we decided that we were going to launch into what we called early access, which was sort of a strange thing for an audio company, but we did it. And we're really glad we did it because we have over 20,000 beta testers in our community now. We have 2 different sort of tracks that we're approaching the community with. One is early access, one is beta. Early access is where we test core functionality, things like Apple M1, M2 silicon processing or AMD GPUs. And then beta is where we're actually using our SDK, which we revealed 2 days ago, to produce plugins. So about our mission to power up the accelerated audio future. So a lot of you guys probably remember, GPU-based signal processing experiments in the past. The number one question we usually get from developers and end users is, why hasn't GPU audio really been further developed before now? And it really is, I guess you'd say, like $1 million issue. It's a problem that had not been solved in the past. I'll try not to go too deeply into the details of how we solved it because we did that the other day. But really, the big question here was like, there are no SDKs, there are no reliable ways in software or tech stacks, no APIs, nothing like that coming from NVIDIA or AMD. So the short version is that we wanted to try to come up with a way to make it possible to use traditional designs of DSP algorithms, reliably parallelize those for GPU processing on GPU architecture, and then execute those things in real time. So we discovered a lot of different, very interesting technological, I guess you say, innovations throughout the process that has thus transformed into the current SDK. So there are a few problems with GPU audio in general. The difference between MIMD and SIMD devices, one is inherently sequential, one is inherently parallel. When we're dealing with parallelism and sequential DSP, there are many issues. So the first of which is obviously parallelism. The second one would be handling multiple tracks and effects. The third one is going to be on the handling of the data transfer between the CPU and the GPU. So these are what we call the three main challenges of GPU audio that we embarked on a journey to solve. So the way that this came about is through our core component that we call the scheduler, which is I guess you'd say our main solution. There are a lot of solutions. As Sasha can attest to, there's just like enumerated or just numerous challenges associated with it. But the primary challenges of latency and everything has been solved through the scheduler. So basically, our scheduler is actually two schedulers. Combines a host scheduler and a device scheduler. So the scheduler is capable of chain blueprint management and generation, handling simultaneous tasks, execution blocking and dependency resolution, execution time prediction, and much more. Only by combining execution requests and relying on a fine granular task-based execution model, we were able to reach real-time audio processing performance. So this line of reasoning is what led to the creation of the scheduler. And in short, the purpose of the scheduler is to run hundreds or even thousands of effects assigned to audio processing channels within 150 microseconds or within 1 millisecond of latency when applied to a VST3 model. So the result is that we ended up with fast communication between the DAW and the GPU that allows your GPU to process high loads of DSP without adding any latency, whether you're scaling the number of tracks or instances of a plugin or et cetera, or adding channels and effects. It just really doesn't matter because of the way that we're able to cascade across those. So let's see what's more. So let's get into the results. So as a result, we have major gains. Algorithms designed by GPU audio are able to achieve significant speedups over CPU processing in both real-time processing and in offline rendering use cases. So for inherently parallel effects and traditionally sequential tasks, we're actually seeing a lot of huge benefits, which is part of what led us to want to turn this into a standard that everyone can use. So for FIR algorithms, GPUs can be used to speed up real-time processing by 40x. For rendering, it's approximately 75 times faster than real-time in some recent tests that we did. When we're running IIRs, which obviously are traditionally sequential with some parallel designs, we are able to get speed up in real-time processing by 10x. And for rendering, we're able to get 50 times faster than real-time. So when we're talking about the real-time use cases, by the way, obviously that is different than offline rendering, and Sasha could always go into more details on that later. So we can also take the multi-GPU system and put some laptops surrounding it with a network connection and say that we can also achieve these results when networked together. So that's sort of like the super fast version about what scheduler does and the core components. If you were part of the workshops earlier, you got more information and we'll have more info about that. But with that, I'm going to pass it back to Sasha, and he's going to tell you about where GPU audio can be used in your projects.
Okay, thank you, Jonathan. So basically, I want to tell you some brief message, like how should you think about what GPU audio offers. So this is not only about whether GPU is faster than the CPU. This is mostly about how we harness the power of GPUs. So for example, NVIDIA's RTX 4090, it is 18,000 cores GPU and each core is running 2.0 gigahertz or something like that. This is tremendous amount of power that we are harnessing for you guys. And when we say that this power can be applicable to the entire variety of applications, you have to think about it that we run DSP components, we run DSP designs on the GPU at scale. So you can think about it like you can run multiple instances of plugins. Any plugin you can port on the GPU, including those that have some data dependencies in the DSP designs, non-plugin software. So if you want to go to spatial audio, rendering, editing tools, and this is like standalone tools for your live performances or whatsoever, we can do that too. You don't need to connect this to the DAW. The entire GPU audio engine can live pretty much anywhere with anything running together inside the one GPU or multiple GPUs. We can connect DAWs to the GPU and can do things just beyond the traditional, I would say, audio workflow. So imagine like 2 years after this conference, someone will bring integration to the Unreal Engine, right? So this is also possible. There are ways to integrate Unreal Engine in virtual production to the DAW. So we are aiming to provide this kind of integrations, and you guys can do that on your own with our open SDK. Cloud-based platforms. So SDK, GPU Audio SDK, and our solution allows you to code things once and to get it built for all of the GPUs you know for today. NVIDIA, AMD, Intel is not there, but will be there soon once you will start buying those GPUs. Mac, and you can have this code deployed pretty much anywhere, like embedded GPUs, cloud-based GPUs, doesn't matter for us. Machine learning, AI-powered solutions, again, wherever they are actually deployed locally on your laptop in a form of plugin that works on inside your DAW, for example, tone transfers, adaptive noise cancelers, or some web service, I don't know, dense diffusion model deployed, and you provide a service for like consumer level, everything is possible to be powered with GPU. Well, and one thing like embedded GPUs, I will call it again, in particular because there are some synthesizer companies that are willing to embed GPUs, and we have some discussions with them. So today's agenda for this sponsor talk is basically 3 parts. First, what's done as of today, what's coming next, and what we'll do in the future. So let's get started. What's done today? Well, this is a timeline, almost like official timeline of our company. There is like unofficial part of it, and we were sort of stealth startup. But since this year, we started revealing some things that we already managed to build inside the company, and we started releasing them. So we started with the early access launch, which was FIR Convolver that worked back in the day in June only for Windows, NVIDIA, and VST3 format. Then we made a huge progress, organic progress, like marketing thing, organic progress to onboard more than 20,000 users. So we almost didn't buy any advertising, just made a very tiny branding stuff. So I believe this is sort of success. Then we started with bringing the new thing, which is bundled plugins bundled together. And we started with the modulation bundle, which is made of flanger, chorus, and phaser. This thing works for now only with Windows VST3 NVIDIA, but the early access plugin, which is FIR Convolver, works with AMD. And with the time, we will start bringing more hardware platform support as we go, as we release more software. So the first thing is like NVIDIA, then AMD, then Mac OS X thing. Exactly to the Mac ecosystem part. So we have plans to release FIR Convolver version for the M silicon systems, particularly on GPU. We don't use CPU for computing. So we will do it like within a month, just a few weeks or so. We have internal version working already, and we pass this to QA. Later on, next year, early 2023, we are going to reveal third-party product collaborations with the other companies. The first one is Mach 1 Tech, and we will talk about it today a little bit. And we're going to make our SDK publicly available. So SDK is already sort of done. You can sign up on the website. You can always outreach us and ask for SDK to play with. I know that most of you guys have Mac systems, right? And this is the reason we brought to our ADC22 workshop NVIDIA-powered cloud solution like Cloud IDE to allow you code on Mac in the web and to get things compiled, built, and running on the NVIDIA-powered GPU servers. So we can provide you the same case in case you are in a hurry and you want to start playing earlier. So we want to reveal the SDK in 23rd year. The first thing that we need to do before that is to build the right, I would say, a developers community portal, because we don't want to be like a Steinberg. Put in your archive to the web and do nothing with this. We want to provide you with use cases, examples, stories, and we want you guys to actually start using it in the right way. And one cool thing we already sort of announced, we revealed the GUI part only, unfortunately, the synthesizer. This thing, yet another thing that we will discuss today later. So here is the entire variety of things that we have released for today. As you can see, guys, we have the FIR convolver on the right bottom corner. This thing works without bundle. You can't put it in a chain yet. The rest, like modulation bundle, phaser, chorus, and flanger, you can put in a chain. You can run them all, and you can have a decent amount of performance with this thing. We work with low latency, within 1 millisecond latency buffers. Just sign up, download, and try. We support Windows, NVIDIA, and AMD. AMD limited support for FIR convolver only, and for some certain device, these are dependencies from AMD. So once they will figure things out with their drivers, we will extend our support for the other devices. So we just dependent on the drivers. What's next? Yeah, so exactly what's coming next. So this is the modulation bundle. You can barely see it here on projector screen. I will just read it loud. So modulation processing bundle consists of phaser, flanger, and chorus. There will be another tool that we will release, which is called modulation. The next bundle will be sort of stereo field processing. There will be 3 plugins available straight away. Fireverb, which is convolution reverb. You can upload custom IR there. FIR convolver, the same that you know already, but this thing will work inside the chain. The delay and stereo tool we will release later. The next one, frequency correction. So we have already compressors and multi-slot compressors with crossover enabled, already implemented internally in some ways. We will just release it as we go, I hope like each 2 months. Limiter, gator, and transient shaper will not be a part of the initial release of this bundle. The next one, distortion devices. Both of them we will release initially, single slot and multiple slot with a crossover enabled, I guess. Dynamic processing. Yeah, so regarding the dynamic processing, we'll release parametric equalizer straight away. Exciter is already done, already working. Probably tender, probably filter. Analyzer will not be included in the original release. Yeah, so regarding the Mac thing, I just want to mention that it is extremely important to let you know, guys, that it is hard to bring the tech, okay? Like, you can't do it just straight away. There's no APIs, there's no SDKs. You can just have a fancy coding and programming and just bring GPU-powered stuff. We do a lot of things to support even our own products SDK-wise, and I'm happy to share with you some insights regarding our implementation for M-Silicon GPU powered systems. So we can have up to 4,000 real-time, 4,000 X real-time scaling in bounce mode, and we can run, I guess on M2 Air exact MacBook that I own, we can run up to 512 channels in real-time mode with 1 millisecond latency, and CPU usage for Apple ecosystem shall be cool 0, because in the VST3 we still have some issues that we need to resolve. Yeah, so I want to pass a word to my partner Jonathan, and to basically tell you more detail what the partnership with Mach 1 company is all about.
Hey guys, hopefully you can hear me just fine. So yeah, as Sasha was saying, you know, and I like to kind of prep this by contrasting to what we've been building. So what we've been building on our side is what we consider to sort of be like a bread and butter toolbox, you know, of everyday useful tools. And the original vision behind that was the idea of, okay, a lot of people are out there using a extremely CPU overhead, you know, intensive plugin that is making it so that they have to freeze other tracks and things like that. So what if we could offload most of the basic processes and a lot of the other creative processes onto the GPU in the short term so that people could save their CPU for bigger projects, right? So in other words, they might use our beta bundle, you know, once it's fully out to handle most of, you know, all of the day-to-day stuff and then save their CPU for something that's really heavy. Well, when we work with partners, it's the flip side. On the flip side, what we want to achieve is we want to partner with third-party companies. And this is like our, you know, we have companies out here that have been spending decades or years, you know, becoming experts at creating incredible products, and next-gen products are on the roadmap. So we want to power those companies up. So we have a whole bunch of partners, but one partner that wanted to be sort of introduced this year was Mach 1. I'm sure that you guys have probably heard of Mach 1's SDK. It's a really well-known SDK. It's fantastic. They do sort of like vector-based spatial audio applications, very low overhead. And we are building a next-generation spatial audio mixing platform with them that will allow you to offload processes from your DAW and mix them spatially without limits, and return all within, you know, the classic GPU audio 1 millisecond latency. So really looking forward to working with them this year, and working with other companies that are doing similar. One thing I can mention is that we do have a pretty exciting partnership also with another engineer named Dave Pinsato. I can't get into all the details yet, but we are planning something really awesome with Dave and a bunch of other companies as well. So, you know, big props to Jackie and Dylan over at Mach 1. Unfortunately, I can't share all the details about what they're building just yet, but we will do a separate presentation soon on that. So when we're getting into the rest of what we're doing, so Sasha mentioned quite a bit about the developer tools and portal. This is a project that I'm helping to spearhead, and we're going to be launching this in 2023 in Q1. Like he said, right now, if you want to get your hands on the SDK earlier, we can make that available to you. In order to do that, you would just go to gpu.audio/SDK, or you can just send me an email, get my email from Sasha afterwards if you're interested in it. But in general, the SDK is going to be layered, which means you don't have to use the entire thing. It's not all or nothing. If you just wanted to take advantage of a certain aspect of it, you will be free to do so. It will move you towards low latency GPU-powered results with high performance DSP. And I feel like Sasha already covered quite a bit of the SDK, so you know, we're free to move on that. But yeah, that will be coming Q1, and we will make the portal, you know, similar to like Unreal Engine, that type of thing, where you guys will have projects and examples and things like that that you can go through. So the schematics of the SDK, I can kind of run you through those really quick, unless Sasha wanted to.
Yeah, Jonathan, if you don't mind, this is my part of the presentation.
Oh, yeah.
Thank you.
You got it.
Okay. All right, guys. So the GPU audio SDK, it will consist of multiple layers. All of those layers will be independent from one of another. So there will be GUI SDK. I'm sure that we will release this as late as possible, but the GUI SDK will be the web-powered SDK. You can basically turn on any GUI as a web code, just like the way you do it for Chromium embedded framework. If there are any plugin companies using Ceph to turn on the graphics, this is the same thing. The cool advantage about that is that you can create photorealistic GUI just like that, like in 2 weeks, any GUI. So we will let you cooperate, and we will provide you the full access to this layer. You can use it without GPUs, without anything. You can extend it without GPU audio SDK. This is sort of free real estate. Another part, this is basically GPU audio engine, the scheduler. This will be necessary to use it in case you want to either build your own products, and you want to build your own products with our DSP component library, or you want to write something from scratch, whatever you want to do. This SDK, again, this will offer you a possibility to write code once, C++ way, and to get everything built for multiple platform support, including NVIDIA, AMD, Windows, and Mac ecosystem thing. And we will also provide our standard ways to integrate the products you built with the DAW through our own VST3 integration and audio unit integration. And certainly all of that thing will be working with latencies as low as 1 millisecond. You can run anything you want at scale. Yeah, so how this thing, what's the SDK typically, DSP part of the SDK look like? So the core thing is GPU audio engine, which is the scheduler. There are 2 APIs behind that. One is the most important processor API. This is low-level API. So if any of you ever played with GPU code, like tried this with shader languages or wrote some CUDA programs or OpenCL or whatever it is, this is basically the API we offer you to run any DSP algorithm of your design. And you can basically implement any algorithms utilizing barrier synchronization, which is a very primitive, very basic primitive for the synchronization on the GPU, and the other API and tools we offer you. So your product, your component will be scheduled, will be managed by scheduler, and the other products too working simultaneously. The another part of the API is DSP one. So this is basically just to organize the entire data flow through the DSP components inside your product, or like product processor, speaking VST3 wise. And the most important part, the free part, DSP components library. So all of those things that we introduced you during our workshops and the talk yesterday, like IAR, sort of IAR filter implementation. Just one more thing I wanted to say. This is not exactly the IAR, because the classic design cannot be parallelized by nature. You have to think over how you can actually find the other design that can allow you to implement the same transfer function and provide you the same formula curvature. That's the trick, okay? And all of these designs are GPU friendly, SIMD friendly. So we offer you like standard filters, FFT, all that kind of stuff. You typically need to create pretty much standard DSP, digital sound processing solution. Yeah, so this is basically the way how it works for a developer. So you have where to start actually, right? You have your own code, C style, pseudocode, anything, right? In mind of old product you want to migrate, make it GPU powered, or you want to design the new one, that's your dream product. You were sort of waiting for the power to turn this thing on, right? So you just need to code it thing once for CPU. Then you sort of need to port it to the GPU. In a sense, you can go the 2 ways previously. You can re-implement it on your own, or you can call us and make the collaboration. We can do this for you. Or you can try to reassemble things through our DSP components library. Then definitely once some prototype is done, you need to optimize those things. And then you have to basically build the component and use it. So more things that we promise next year. Yeah, the major synthesizer. So this synthesizer was, I'm not sure if you see this here on this screen, but anyways, this synthesizer was inspired by sort of Rapture. Okay, Rapture and Synth. This is multi-layer synthesizer. You can have like 8 synth voices, 8 sample voices, 16 voices per oscillator. You can apply randomization of parameters, and you have the Eura effects rack, so like typical thing, but running on GPU with low latency. And basically, this is how you can see you can build the products with GPU audio SDK for which vertical or niche you want: broadcast, 3D immersive audio, post-production, virtual production, cloud collaboration, etc. These guys are supporting us directly, and this is non-typical support. Usually startups say that we collaborate with someone by just buying their devices. No, this is not the case for us. We co-start together. We send some stuff to like AMD. They send our like patched things, and we just release this. And one most important thing that I want to announce particularly today, what the future holds. So I know that some of you guys started experimenting with machine learning, right? And there is one huge problem with this. Typically you are working with the audio thread, right? And you don't want to get all of the resources allocated inside your audio thread, which makes typical developer workflow non-relevant for the audio cases. When you just write your code in PyTorch, you use some pre-built, pre-trained models, and you feed them, and you want them to release for the backend, for the C++, and then to reuse it in some sort of a product. There is a lot of the limitations. We just mentioned some of them. And it seems that the solution for this is to implement Inference Engine, right? So there are some companies, there are some initiatives that are already doing that, like RT Neutral. They are doing this for CPU, but quite obviously the best device to execute GPUs, to execute neural networks, hundreds of layers of those, is a GPU, right? So what we offer to re-implement the backend for Inference Engine and to provide the ways to integrate this in the Python world when all of the machine learning developers work with the front end. So this thing can actually allow you to code things on the front end side, and export is a sort of library that it can furtherly connect to whatever you want. And we might probably promise one more cool feature. I don't see it here, which I personally call continuous learning, which is basically a backward propagation thing. Something is already done by Facebook. You can visit GitHub, a Facebook incubator, and see AI template or something like that. This is already done generally for neural networks inferencing on GPUs. We want to use that or not using that and provide better ways to integrate for audio development workflows. Yeah, so this is just all of the features that we promise to bring with the GPU Audio Inference Engine that we'll bring next year. And thank you, guys. Thank you for joining us today. Scan QR codes, join us, sign up our Discord community server. We have a developers channel there. Sign up to our website, download stuff, provide with feedback, positive, negative. And thank you for being here today.